Good morning. My team and I are going to do a presentation of data analysis processing. This presentation includes the group members' introduction, the introduction of the presentation, our research questions, data processing, data aggregation, data visualization, and finally machine learning. These are the group members in question. It includes Amazul Hakim, Lee Tong Min, myself, Muhammad Azim bin Muhammad Nazlin, and Zaharul Nizam Hakimi Shobri. Now we go on into the introduction. Retail is the process of earning profits by selling consumer products or services to customers through multiple channels and distributions. Customers continue to shop at retail stores to satisfy their needs, which range from groceries to electronics. In this project, we will work with Walmart retail dataset and with the primary goal of getting a better understanding and knowledge of customers' buying behavior when it comes to domestic products, as well as other factors that influence consumers' purchasing decisions. Now we will proceed with the research questions we have. On our dataset, we asked the question, what is the percentage distribution of the customer segment? What are the daily trends by weekdays? What do the sales and profits look like compared to each other? What did the trend look like over the period of the order date? What are the predictions of the sales for the next year, including December 2015? And finally, the variation of product analysis on product category and product subcategory by region. Now we will proceed with the data processing. We will first need to search the null values within our dataset to clean these up and make sure they don't conflict with our analysis on it. First, we use pandas and matplotlib. We import it into our Python programming, and we first need to scan the entire dataset for any null values. We use a combination of isNull and sum function together. After we found out that these null values exist and where they exist, we first then fill in these null values. We choose to fill in these cells with a medium of the entire data, so they will not conflict with anything within our research. Now we will go to data aggregation and my next colleague.
So the next part is data aggregation. The purpose of data aggregation is to help us summarize important data for reporting or visualization. The first insight that we want to acquire is the breakdown of the customer segment column. We compute the sum for the number of records column and call group by with column customer segment to group the number of records by customer segments. Then we calculate the percentage count for each column and edit them into a new column percentage. As we can see, the corporate customer segment has the highest number of records at 36.62%, with consumer and small business having the two lowest counts below 20%. Next, we want to look at the best performing regions. We group the region column by sales and compute the sum of sales for each region. The center region is the best performing region with sales of approximately 4.7 million. The other regions such as East, South and West are not far behind at over 3 million sales each. Again, we group the region column but by the sum of profit this time. With this aggregation, we can compare the sales and profit for region later. It is no surprise that the central region has the highest profit since it has the highest sales. However, the South region managed to make the second highest profit despite recording the lowest sales. For our next aggregation, we would like to look at some trends. The order date will be used, hence we call the order date column to have a look at the data. The order date has a date-time data type with a year, month, day format. We can analyze trends by year, month or day, hence we need to have different timestamp of the data. To do so, we use data time index module to output the year and month values of our date. The dt dot The day name function is used to return the day names. The new timestamp are added into new columns year, month, and day name. Now we can make our first trend analysis. We want to look at the sales, order quantity, and shipping costs based on the year and month of the order date. We group the data on year followed by month column, then apply the sum on sales, order quantity, shipping cost columns. Then we use the head method to view the first 5 rows of data. We then follow up with product analysis where we look at the sales and order quantity which will be categorized based on product category and subcategory. We group the data with a similar method as before and were able to display it using the same head method. Next, we analyze the daily trend sales and order quantity by categorizing the data based on day name and product category. We make sure that we use the same grouping methods as before to aggregate the value and to round the sale to 2 decimal places to match our currency. Next, analyzing top trends require us to simply group our data by state and product name for the column. But other than that, we unstack the values to produce a more representative display of our analysis. Next, we retrieve the top 5 state by sale for each product category. Simply sort the sales and finisher in descending order, then use the head function to retrieve the first 5 rows. We simply repeat the previous step for office supplies and technology category.
Hello everyone, I'm Tongming and I will be explaining about the data visualizations of our project. For our first analysis, we visualize the percentage of customer segments in a pie chart using the plot function. The auto-PCT argument is added to display the percentage and number of records for each segment. As we can see, the retail sales mainly come from corporates and home offices. Consumers and small businesses have the 2 lowest record counts, both with percentage below 20%. Next, the sales and profit based on the 4 regions, Central, East, South, and West are compared in a line and bar chart using the twin X function. The sales is represented by the blue bars, while profit represented by the red line. You can see that Central region recorded the highest sales as well as the highest profit. It is also interesting to see that the South region making the second highest profit despite recording the lowest sales. For our third analysis, the trends of order quantity, sales, and shipping costs across the period of order dates are visualized by using subplots. The year and month are displayed on the x-axis, and from these line charts we can see that the sales started the year 2012 at peak, then dropped and remained stagnant until it increased back in November. For the next 3 years, there were some dips and spikes, but we can deduce that spikes usually happen at the end of the year, possibly due to the holiday seasons. Next, I would also like to analyze on our findings from the product analysis by product subcategory. Again, order quantity and sales across the 17 product subcategories are compared in the bar charts. It can be seen that most of the products are inversely correlated between order quantity and sales, as cheap products are usually bought in a high number but in the end only contributing little in terms of sales. A few obvious examples are paper, envelopes, and also labels from the office supplies product category. On the other hand, products that contribute more in sales but have relatively low quantity being sold are office furnishings and tables from the furniture product category. Now, we will look at the product analysis by region. For this analysis, we illustrate the correlation between the 2 variables, product subcategory and region in 3 different heat maps for sales, order quantity, and profit. The degree of correlation is determined by the value and represented through colors ranging from green to red. Green squares indicate a higher correlation, and the red squares the otherwise. We also displayed the daily trends for sales and order quantity for 3 product categories, furniture, office supplies, and technology in stacked bar charts for our 6th analysis. For sales, both office supplies and furniture have repeating upward and downward trend over the week. Besides that, technology has a sudden spike on Tuesday, which is also the highest sales of the week. For order quantity, there aren't significant trends occurring for those 3 product categories, except on Tuesday, which all of them have the highest order quantity of the week. And for our final analysis, we represent the top 5 sales by state, categorized by furniture, office supplies, and technology. The bar plots provide insight on which states have the highest sales and customers' preferred product in each state. The California state is the highest consuming state of all 3 categories, beating all of the other states. Other than that, Illinois has the second highest in furniture, Ohio for office supplies, and also Texas for technology. Similar to the California state, Texas and Illinois also have huge customer bases, as they make it into the top 5 sales for all 3 categories. So I think that's all for the data visualization part. Thank you.
Hello everyone, I'm Saharul, and now I will continue to present for the machine learning part. So after we have done all of the data processing, data aggregation, and group operations on the data set, we will now be splitting the data into 2 sets, which are the training set and also the validation set. For both sets, we have the targeted field that we wish to predict, and in this case, it is the sales column that we start as Y. And we have some other fields that will be used to train the model. However, not all of the fields will be used. Thus, we created an all features variable to store the selected field name. Then, the selected fields are stored in variable X. We can then split the data into the 2 sets. Instead of using the train test split module, which is built in the scikit-learn library, we split the data manually because we want to preserve the index arrangement. However, the training and validation set are still not quite ready yet because some of the fields are not understandable by the machine learning model due to their format. So, we basically are going to convert those fields, which are the categorical data basically, into numerical data so that it is understandable by the machine learning model. In order to do so, we created a list name features to store the understandable field, and then we filter out the field that we want to encode into a variable name encoded column. Then, we need to import the one-hot encoder from the scikit-learn preprocessing, and then we can encode the categorical data and store it in another variable. We then remove the original categorical data from the data frame, and lastly, re-adding the encoded data to the data frame in order to replace the original categorical data. Next, we are going to build our first model, which is the decision tree regression by importing the decision tree regressor. We set the random state to 1 to ensure that we get the same result every time we run the model. Then we train the model by fitting the training dataset to the model. We make prediction on the validation set by using the trained model. And lastly, we measure the model performance by calculating the mean absolute error. We also created another decision tree, but we specify the maximum number of leaf nodes that the tree can have, which is 100, and then we compare the MAE value, and we get that the first model performs better as it has lower MAE value. We also train another type of model, which is the random forest regression by importing the random forest regressor. So basically, the process of building, training, and testing the model is the same as the decision tree model. But in this case, we try to find the best model by iterating the n estimator's value and to get the MAE value. Then we compare the MAE value and we get the best model is with the n estimator value of 15, resulting in the lowest MAE value, which is 127.7176. Thus, we select the random forest regression model with the above parameters value as our model for the prediction. Then we make the prediction. After we have done the prediction, we store the predicted values with the actual values in a new data frame. Here we can see the comparison between the 2 values in a tabular form. We also plot the 2 values in a line graph so that we can see it more clearly how the prediction and the actual value varies. So on the left side, we can see that the whole plot for the whole year of 2015, and on the right side is basically a drill down of the graph for the December 2015. We can see that the predicted value did not vary far too much from the actual values. Thus, we could say that our model performed quite well in this case. And I think that was it from us. Thank you and have a nice day.